and just keep going down that list. This is now f of 1, f of 5/5 plus, and we're almost done with this. This is the 6th one. This is the 7th one. And this is the 8th one. Now remember the last one, n equals 8. We do not have a 2 here, so it's just going to be that of, in this case, just 2 itself. Okay. Now some of these are going to be easy to deal with, right? Like this is the first one and last one. The other ones are like 1 as well, right, when it comes to it. So here we have 1/8 times f of 0, just plug in 0. That just gives you 1. That's a nice little tidbit there. Plug in 1/4 into there, and then times it by 2, we get approximately 1.969. And do the same thing. Plug in 1/2, and just don't forget to multiply by 2 once you're done. And this, again, another easy one. Plug in 1. That's 1/2. And 1/2 times 2, again, that gives you a nice 1. So a couple of these aren't too bad to deal with. Just take your time when it comes to your calculator, because you do not want to mess up, plugging a couple of these numbers in and so forth down the line. And again, plug in 2 to there, and gives you approximately 2, when it comes to it. And again, adding all of these up and then dividing by 1/8 gives you almost identically to this. Well, to 3 decimal places is exactly the same. If you go a little farther, they change a little bit, but essentially you get the exact same thing at a certain point of rounding to decimal places there. Okay. So that is using the midpoint formula, or the midpoint Riemann sum, and now using the trapezoidal rule to find the areas underneath curves themselves. Okay. Because as of now, this is a pretty difficult question to figure out, just using basic integration. So we always have to go back and just use a basic process to find those areas to make it far easier to deal with, right, when it comes to it. All right, let's do another example so you guys get more practice when it comes to it. Okay. So same thing, we want to find the midpoint, using the midpoint Riemann sum and also the trapezoidal rule. We find the integral of sine of t over t from 1 to 3 dt. Now remember, t and y and all that is just a variable, right? So as long as, it's the same as if it was x, so don't biggie when it comes to this case itself, right? All right, so let's just do the midpoint first, and then we'll do the trapezoidal afterwards. So in this case, now we want 4, so a lot less work to deal with, because now we basically cut everything in half, right? The amount of work we did earlier. So we want midpoint one, just 4 of them itself. Okay. So same thing, I want to, from 1 to 3, I want to cut that into fourths, right, when it comes to it. So using our change of x, so again, change of x is equal to b minus a over n in this case. So this is going to be 3 minus 1 over 4. So this is 3/4. So therefore, each rectangle is approximately 3/4 away from each other. So that's how we identify that process there. Okay. So we know, starting from 1, and just adding 3/4 to it, so that's 3/4. Add another 3/4. Oh no. Yep, that's right. Add another 3/4 gives you 4/2. No, 7. What am I doing? 7/4, and then 9/4, and then finally 11 over 4 as your midpoint ones. Okay. So those are exactly our midpoints themselves. Okay. So therefore, according to our equation, again, it's going to be 1/2 f of all of these put together. And again, I'll just do a couple of these. Believe it or not, actually, it's all the same, which is pretty crazy. So f of 1 or f of any of these actually gives you almost the exact same thing again to 3 decimal places. And these are all the same. So again, if you don't believe me, try it out on your calculator. Pretty crazy. So again, adding them up and then dividing this by 2 gives you approximately 0.035 as its area. So again, that's using the midpoint Riemann sum. Okay. So same process, we're going to use the trapezoidal, just like we did in the last example. So again, n equals 8. So in this case, it's going to be a change of x, which is 3/4, divided by another 4. So that's going to be oh no, this is a 2. That's why I was a little confused. Yeah, that's still good. So cutting this in half, that's good. So it's just 2 over 8. 2/4 divided by 2. That gives you 2/8. That's perfect. That's what I was looking for. 1/4. This is going to be 1/4. Okay. Starting from the beginning, f of 1. So you always start from your starting point. Plus 2 times. And again, this is where you change of x. So if you want to find your next term, it's going to be a's, which is 1, plus 1 times our change of value, which is 1/2. So this is 1 and 1/2. Or if it's easier to do that, it's going to be 3/4. All right, 3/2. Keep going. Oh, f. So same thing. This is now a 2 instead. So 2 times 2 is just 1. Right? 1 is going to be 2. Plug in 3. This is 3/2 plus 1. That's going to give you 5/2. And then the last one, we know it's going to be f of 3. That's our starting point, end point there. Okay. Well, again, right, so believe it or not, these all end up being roughly the same. This is the same as over there. It's 2 times it, so it's going to be just 0.035 for each one. And again, just plug it in, and these pretty much give you all of the same as well. Except for the last one, a little different. Oh, I'm missing one, so plus 0.035 for the last one. Okay, and then again, adding all these up and dividing by 4 gives you this here. So they're finally a little off when it came to this example. But again, very, very close to each other. Right? So if you're around the 2 decimal places, they're exactly the same. You go a little farther out, that's when everything will changes. Again, depending because it's not perfect itself. Right? Trapezoids are not missing some area, and same thing with the midpoints are either missing or including areas that should not be in there. Okay. Right, so that's the first part of this section is finding the midpoint and trapezoidal rules and finding those areas using those rules itself. Okay. Now, like we noticed, right, there's some errors. Right, this one's a little off, but which one is correct? Right, which is the better error, or which was the better one to deal with? And that's what we're going to talk about now is error bounds. So error bounds using the midpoints and trapezoidals, or in other words, how much error is there using each individual case itself, okay? And this definition is very, very theoretical. We'll try to break this down as much as possible. This one says, suppose the absolute value of the second derivative of x is less than or equal to some value k for all x between a and b. Then the error bounds, meaning you can find the error within this portion, is equal to the absolute value of e sub t, which is the trapezoidal one, and n represents the midpoint. So first, the error of the trapezoidal rule is less than or equal to that same k value times the difference between a and b squared, or so this is a and b cubed actually, these are cubed, a and b cubed divided by 12 times n squared. Okay. And then the error bound for the midpoint is very, very similar. The only difference is you divide by 24n squared instead of just 12. So the equations are pretty much identical to one another itself. Okay. But the question is, how do you use this, right? There's a lot of theory when it comes to it, and it's actually not as bad as you may think as well. So let's just try an example so you can see using our error bounds formulas themselves, okay? So example 3 says, estimate both errors using n is equal to 10 for the integral from 1 to 2 of e raised to the 1/2, 1 over x dx. Okay, so we want both errors, and that's what we're asking for here case. Okay. All right, so let's just first use the easiest of the two, I guess if you call it, the trapezoidal form. So we know that x is between 1 and 2, according to our scenario, right? That's what it means by 1 and 2, so that's between a and b. Okay. So now what we're going to do is we're going to find the second derivative. So we know our function is e to the 1 over x. So we take the derivative of that, first derivative. This is a chain rule one. No, use I guess you use your chain rule. Yeah, chain rule one, right? And let u equal 1 over x. Take the derivative and take the derivative of the outside. So this ends up being negative x squared e to the 1 over x.